math lovers, welcome to notes number 48. I've got two different worksheets for us to think about today. The first one's just a warm-up. This is a review from yesterday, what we did with basic transformations and of functions. So, think about how these are going to change. If we were in the classroom together, what I probably would do is have us go through and just talk about what the transformation is going to be. Like the 4 on the outside here is going to make my parabola skinny. The inside -4 is going to make the parabola move to the right, and the +3 is going to make it move up 3, and this negative sign is going to make it open down, and 2 is going to make it more narrow. So I'm going to multiply all of my y values by 2. And so we would go through all of these values. I encourage you to give these a shot. The answers are posted, so you can check your answers with those, but definitely give those. There's just a good practice on front and back. And I tried to pick one of every kind of the parent functions that we've been working with here for you. So if you don't have this page, I'll post the blank one in the comments so that you can follow along with us. What I really want us to do is to think about transformations of functions today in terms of something that's not necessarily one of the big 8 parent functions. I want to give you some kind of random function. This is from Ron's book on page 224, number 11, and he gives us this graph. Okay, so this is our parent function. This is our parent function that we're going to work with. It looks a little bit different than what we're used to. Notice that he gives us the ordered pairs. The ordered pairs for us to use here, he uses 0, -1, 1, 0, 3, 1, and 4, 2. So what I did is I went ahead and I cut and pasted this original parent function 9 times on your paper so that you have this parent function to go ahead and graph. All right. So we're going to do these 7 different transformations right here that Ron gives us, and we're going to use these core points. So again, first thing I did, this is our parent function, and I wrote down a table here with our core points that are given. This is our given. Okay, so now we're ready to start our go ahead and graph. So I'm going to try to zoom in a little bit. Okay, so you guys can see everything that's going on. Our very first one that we're going to do, letter A, has the function f of x and is an outside +2. So f of x +2. So I'm going to take each of these coordinates and I'm going to add 2 to their f of x value. So really it's essentially just a shift of up 2. So each one I'm going to take the ordered pair and I'm just going to shift up 2. 1, 2. And then I connect the points and there it is. You can see that the whole graph has shifted up 2. If you wanted, you could take your core points. You could add 2 to each of the f of x's. In the next one, letter B, we have f of x -2. All right, so our function is equal to f of x -2. That's an inside 2, right? Inside -2 is going to move everything to the right 2. So I'm going to take each ordered pair and I'm going to move to the right 2. And then I go ahead and I connect them. All right, we can see that the whole graph has shifted to the right 2. All right, letter C, we have 2 times f of x. Okay, so I'm going to shift up a little bit so you guys can see this. Okay, so what I'm going to do is I'm going to take each value of f of x and I'm going to multiply it by 2. So I'm going to go to our core points that we had up here. Remember our core points were, let me draw them out for us, were 0, 1, 3, 4. And our f of x's were -1, 0, 1, and 2. So what happens in this function is first you do whatever the f of x function is, and then, and then we're going to multiply every single one here by 2. So they all get multiplied by 2. All right, so what we're really doing is we're stretching this graph. We're going to do a vertical stretch. So I have 0, -2, so the point here should be 0, -2. And then 0 times 2 is 0, so 1, 0, that's going to stay right there. 3, 3, 2, so that goes up here. And then 4, 4, so 4, 4. So the graph is stretched out. We can see that. Okay, again, it's an outside 2, so I multiplied all of the f of x's by 2. okay? I should really call this f of x times 2, or I could call this y, all right? Moving on to the next one, letter D, I have the opposite of f of x. Okay, so we know that this is going to be a reflection. This is going to be a reflection. I'm going to take all of my f of x values and I'm going to multiply them by a -1. If you wanted to go back to your core points, 0, -1, let me make a little table for us. 1, 0, 3, 1, 4, 2. I'm really multiplying all of these by -1. I probably should not have written right here on the graph. Ugh, silly me, Glennon. Well, good thing I have another one right next to it, right? I can use this one. So this is x, and this is the opposite of f of x, okay? So I'm going to take each point and I'm going to reflect it over the axis. So I'm going to take the opposite. Actually, it should be okay. I'm going to multiply either of them by negative. So here I am at a -1. -1 times -1 is positive, so here I am right there. And then 0, that's going to stay there, and -1, so this is going to flip down to be 3, -1, and this would be 4, -2. So 4, -2. So the whole thing reflects over the x-axis. All right. Letter E, we have f of x plus 3, and inside +3, inside +3. So each of these coordinates are going to shift to the left 3. So I'm just going to go ahead and count, right? So this should be right here. I'm at 1, so it's -2. I'm at 3, so here I am. And then over here, this is going to just shift. Okay. If I wanted to, I could go ahead and draw the t-table, and I could subtract 3 from every x value to give me my new x coordinates. Okay. Scroll on up there. Try the next one. Let's see. The next one is y is equal to f of the opposite of x. Okay. So what I'm going to do in this one, and I think I'll use the core points here. 0, 1, 3, 4, and then I had -1, 0, 1, 2. All right, so using our core points that they give us, before I even get started with my function, I'm going to change every x value to the opposite. So really, I'm multiplying each of these by -1. Every single coordinate is getting multiplied by -1. So here I am. I take the opposite of 0, which is 0, and there I am. The opposite of 1, which is -1, so I'm going to move to the left 1, 0. -3, +1, and -4, +2. Okay, so here I am, and there's my, oops, it's a little sloppy. Okay, there is the reflection. This is a reflection over the y-axis. And this goes back to what we did in the previous day's notes where we talked about the inside numbers, outside numbers, and reflections. Last one for us today, let's see. It is y is equal to f of 1/2 of x. All right, so this one is a bit different for us to use. I'm going to go ahead and use my core points. Let me see if I can write them down here. I've got x and f of x. Again, 0, 1, 3, 4, -1, 0, 1, 2. Now, what's going to happen here is I want each of my coordinates to give me the same output, the same range. I'm not going to change these f of x's, but what I'm going to do is I'm going to take half of every x to get the same output. So if half of whatever I'm getting gives me 1 to get an output of 0, I really have to multiply every single x value by the reciprocal of 1/2. So that would be 2. I'm going to multiply every single coordinate by 2. Look at that, okay? So 0 times 2 is 0, -1, so that's going to stay right there. 2 times 1 is 2, so I'm going to move over 2 and up, over 2 and up 0. 2 times 3 is 6, so I move over 6 and up 1. And 2 times 4 is 8 and up 2, so that's going to be right there. Okay, So what that really do is stretching my graph horizontally. Okay? So we did lots of transformations today, lots and lots of practice. You hopefully did the practice, not me. You did the practice with the worksheet, okay? There are 24 problems for you to try. And then notes 48, we tried a non-traditional function, okay? Not one of the big ones. And we transformed the heck out of it. All right? Have fun with your problem set, everybody.